Hey guys, Mrs. Traver here. We're going to work through notes today on systems of equations. This is our last of the 3 different types. This is over eliminations. But before we start looking at those, I wanted to refresh our minds first to look at the differences between substitution and elimination. So looking back at our last notes on substitution, what we were ending up doing is solving for either x or y and plugging it into the other one. So like this one, y was already solved for us, so I was able to set this whole version of y into that spot and rewrite. Right here I put it in red. So this 6x plus 23 got put in that y spot, and then we solved. Sometimes only one of the two is solved, and we're able to put it in that spot. So I had right there that originally was just a y. Now it's that whole piece that y was. And the last type we looked at are those where neither x nor y is solved, and we had to solve for it first. So notice I took this one with x plus 5y equals 8, and we moved things around to get x by itself here, and then I was able to plug this version of x into that spot. So substitution is the kind where we are looking to solve for either x or y and plug it into the other equation's version of it. Elimination is a little bit different. So let's look at an example where it would lead us to eliminate instead of substitute. So here's one like that. Example 1. Let's do negative 3x minus 6y equals 9, and let's do 3x plus 10y equals negative 9. So if this was our problem, what I first want you to notice is that we are lined up. This elimination method is sometimes called linear combination. So we are lined up in a combination where the x's are together, the y's are together, the equal signs are together, and the numbers are together. So first make sure you're lined up so they're both in standard form, so to speak. And then notice the coefficients. The 3's are the same but opposite, and then there's the 6 and the 10 and the 9's. Because the 3's are opposite, if I had added them, those would go away. So what's kind of cool is we're going to take these two equations and add them to each other, which looks a little bit strange at first, but we're just going to add component-wise. So negative 3x plus 3x goes away. That's 0. So those guys canceled or eliminated. And then negative 6y plus 10y is positive 4y. And 9 plus negative 9 is 0. From here, I've got 4y equals 0. I can divide both sides by 4. Y equals 0 divided by 4, or just 0. So I've got one of the two coordinates now. Once I have the first, I'd always substitute to get the second. So with y being 0, you can plug it into either this spot or this spot. It doesn't matter. I'll rewrite my first one and put it in there. So we've got negative 3x minus 6 times 0 equals 9. So I've got negative 3x. So I've got negative 3x equals 9. Divide both sides by negative 3. X equals negative 3. So I've got my x and I've got my y. My final answer here, negative 3, 0, is where they cross. Let's do another one. This one, let's have negative 3x minus 2y equals 3, and 7x minus 2y equals negative 7. So this one, we're looking for a combination of x's or y's that will cancel. The x's definitely not. They're not even the same number. The y's look like a better bet, but if I would have added them, they wouldn't have canceled. They would have got me a negative 4y. So I can't add them, but what I could do is subtract them. So we're going to subtract this whole second piece. So that'll end up making the y's cancel out, because I'll have a negative minus a negative is a negative plus a positive. So let's look at our x's first. Negative 3x minus 7x is negative 10x. Negative 2y minus negative 2y is the same as negative 2y plus 2y, which goes away. That's 0. And then 3 minus negative 7 is the same as 3 plus 7, so that's 10. We've got negative 10x equals 10, and x equals negative 1. So there's the first of our two. Now that we've got the first, we can plug this negative 1 into either one of these x values. It does not matter which one. I'm going to put it in the first one. Negative 3 times x, which is negative 1. minus 2y equals 3. Do some simplifying here. Negative 3 times negative 1 is 3. Move that 3 over to the other side by subtracting it. And then divide by negative 2, we're going to end up having y equals 0. So I've got negative 1, 0. All right, let's keep moving along here. We're going to do quite a few examples, 3 more. I want to make sure you see a little bit of everything. Here's number 3. You've got negative 6x plus 6y equals 24, and 4x plus 2y equals negative 10. So this one I'm looking for, I'm always looking for a combination middle cancel. I've got a 6 and a 4 and a 6 and a 2. Neither of those are going to cancel as of right now. If I multiply by something, though, they will. So let's notice 2 is a factor of 6. I could multiply this 2y by something to make it cancel out with the 6. If I multiplied this guy by negative 3, it would make this be a negative 6y. So let's do that. But we can't just multiply one term by negative 3. We have to multiply the whole thing times negative 3. So let's rewrite this guy and multiply the whole thing by negative 3. So negative 3 times 4x is negative 12x. Negative 3 times 2y is negative 6y. And negative 10 times negative 3 is positive 30. All right, this guy, let's just move it over. Nothing happened with it. I'm just setting it over here so it's next to him. Now I've rearranged this one by multiplying everything by negative 3, so it's the same function here. And now I'm in a good spot to add, because these will end out canceling to become 0. So I've got negative 6x minus 12x is negative 18x equals 54. So I've got negative 18x equals 54. Divide both sides by negative 18, and we should get x equals negative 3. So there's the first of our two coordinates. To get our second, we just plug in this negative 3 to either this spot or this spot or this spot, doesn't really matter. I'll use this equation right here. So we've got 4 and then a 7x, I'm putting a negative 3 plus 2y equals negative 10. Some simplifying from here out. 4 times negative 3 is negative 12 plus 2y equals negative 10. Add 12 to both sides. 2y equals 2, so y equals 1. So final answer, negative 3, 1. All right, let's look through another one. Let's see. We've got negative 4y plus 6x equals 0, and 0 equals 3y minus 12x. The first one to notice about this one is that they are not in standard form. So we need to get them like that before I do anything else. Standard form has x's and y's on the same side, and the numbers all on the right. So this one is close to standard form. I just need to flip-flop x's and y's. So let's do 6x minus 4y equals 0. That looks nicer. This one has x's and y's on the same side. Again, they're just in the wrong order. So negative 12x plus 3y and 0. That looks a lot nicer. Looking at our combinations here, I've got a 6 and a 12 and a 4 and a 3. 6 and 12 sounds nice. If I multiplied this top one by 2, then that would look good. So let's do that. Let's multiply this whole thing by 2, and I'm going to put the answer right below it. So 6 times 2 is 12x. Negative 4 times 2 is negative 8. 0 times 2 is 0. Now I've got these two that I can add. So these guys will cancel and be a 0. Negative 8 plus 3y is negative 5y equals 0. So y must be 0. I don't know why we had so many zeros on the sheet. Once you get y, you can plug it in to get your x. So I can plug in this y to any of these spots. If I plug it into this spot, I would have had 0 equals 3 times 0 minus 12x. So I'd have 0 equals negative 12x, or x equals 0. So I've got my point. These ones cross at the origin, 0, 0. So we've worked through several different types of examples. The first one that we looked at was pretty straightforward, where we could add because there was opposites. So my clue to you here is if there is opposite coefficients, then add, because that'll cancel them. If there are the same coefficients, like in this one, then subtract, so that'll cancel them. The last one, number 3 down here, we didn't have anything matching for our coefficients, so we had to make that happen by multiplying by a number so that they would match. And then the last one we looked at didn't have them in standard form, so we had to move things around first to make that happen. We are going to call it a day on these notes. I hope that has helped out, and I will see you guys next time.